All right. Are you ready
Ready for what?
to go deep, deep into web development?
I see we've got another stack of videos to get through.
Yep. Tutorials, career guides, even some project demos, I think. Our mission, should we choose to accept it, is to extract like the essential stuff from all this.
Sounds like a plan. It's interesting how these videos all take such different approaches to the topic. Some focus on learning specific languages, others are all about building actual projects, and some even touch on the mindset you need to really think like a programmer.
Right. And that's what makes it so cool. Like I was watching this one where a guy builds a game discovery app
Oh, yeah.
with dark mode and those loading skeletons. Super cool. I kind of want to build that right now, but first we got to get through this mountain of content.
Well, a good place to start might be with one of the fundamental distinctions that comes up in a lot of these sources.
Yeah.
Front-end versus back-end development.
Okay, yeah, front end versus back end. So it's like
Yeah.
the difference between what you see on stage at a concert and all the stuff happening backstage to make it all work.
That's a great analogy. The front end is everything the user actually sees and interacts with on a website. The design, the layout, the buttons, animations, all that. It's all about creating a really smooth and visually appealing experience.
And the back end is like the engine, right? All the servers, databases, and code that make everything run behind the scenes.
Exactly. And while it's easy to be drawn to the visual stuff, the front end is what we see first. A lot of these videos actually stress that a solid grasp of back-end principles can make you an even better front-end developer.
So it's not like you have to choose one path or the other.
Nope, not at all. Knowing how data is stored, processed, and then sent to the user interface can actually inform your design choices and make your front-end code way more efficient. Kind of like how understanding where ingredients come from and how they're prepared allows a chef to create a better dish.
Makes sense. So we've got this front end, back end thing.
Yeah.
But what are the actual tools involved? I keep hearing about HTML, CSS, and JavaScript.
Mm-hmm.
They seem to be everywhere in these videos. Yeah.
And for good reason. They're basically the fundamental building blocks of the front end. One source called them the holy trinity of web development.
Okay, Holy Trinity sounds important. So where do we start? Which one is like the foundation?
Well, HTML is the base. It's what gives a web page its actual structure. Think headings, paragraphs, images, all those core elements.
So it's like the skeleton.
Exactly.
All right, so HTML is the skeleton, then we've got CSS, which is like, the clothes, like what makes it all look good.
Perfect analogy. CSS controls the look and feel, the colors, the fonts, the layout of the page.
Gotcha. And JavaScript is the one that adds all the interactive stuff, right? Like animations and those dynamic things that make a website feel really alive.
Spot on. It lets users interact with the page, like clicking buttons, submitting forms, or even playing games. It brings the website to life.
Okay, so HTML provides the structure, CSS does the style, and JavaScript brings in the interactivity.
Got it. But how long does it actually take to learn these languages? It all seems kind of intimidating. It's understandable to feel that way. But here's the good news. Most of these videos agree that you can gain basic proficiency in these languages pretty quickly, especially if you have the right resources.
Okay, give me a timeline here. I need some hope.
Well, from what they say, basic HTML you could probably pick up in like a week or two. CSS might take 2 to 4 weeks. And JavaScript, since it's a full-blown programming language, probably a couple months of consistent effort.
Hmm. That's actually not as bad as I thought. But then things probably start to get really complex when you go beyond the basics.
They do. And one of the videos actually introduces something called TypeScript. They call it JavaScript with superpowers.
Superpowers.
Yeah, it adds this thing called static typing to JavaScript, which basically helps you catch errors before you run your code.
So like, it's like a spell checker for your code.
Exactly.
Yeah.
And it's especially important when you're building those large, complex projects where even tiny errors can cause a lot of problems.
But wouldn't that make the learning curve even steeper?
Not really. They say that if you've already got a good grasp of JavaScript, learning TypeScript is more like adding an extra layer of understanding, not starting over. It might even make your life easier as a developer in the long run.
Okay, good to know. And speaking of scaling up and those more complex projects, these videos keep mentioning front-end frameworks, specifically React, Angular, and Vue.js. What are those all about?
Think of frameworks like ready-made toolboxes. They provide a structure, ready-to-use components, and best practices for building sophisticated web applications. They help you write code that's more organized and easier to maintain, and can help you build more complex features much faster.
So they're like power tools for web development.
That's a great way to put it. And just like power tools, each framework has its strengths and weaknesses, making it better for certain types of projects.
Do these sources recommend any particular framework? Like, is there a clear winner?
Not really. They show a few different project examples. React seems popular for building those highly interactive interfaces, like that game discovery app you mentioned.
Ah,
And Angular is often praised for its ability to handle really complex data, making it suitable for larger applications like big e-commerce sites.
what about Vue.js? They mentioned that one too, right?
Yeah. Although they didn't actually use it in any of the project examples, they did say it's another popular framework known for being easy to use and flexible. I guess the takeaway is that the best framework for you really depends on your goals for the project, your learning style, and even just what you personally like to work with.
So do your research and find the right tool for the job.
Exactly. And one of the videos actually made a point of saying that the whole learning process is a lot more fun when you find tools that you actually enjoy working with.
That's a good point. It shouldn't feel like a chore. Speaking of tools, one that caught my eye was Tailwind CSS, which they say can make styling faster and more efficient. But isn't CSS already about styling? Why would you need a framework for that?
Good question. Imagine you're a chef in a restaurant and you have to chop veggies for every dish from scratch every single time. Wouldn't it be easier if you had some ingredients prepped and ready to go?
Oh, I see where you're going with this.
Ah,
So Tailwind provides all these pre-written bits of code that handle common styling tasks, making your life easier and your code cleaner.
exactly. It's like having a set of pre-made building blocks that you can use to quickly assemble your website's design.
And this probably ties in with all that talk about rapid prototyping and fast development cycles that came up in some of those back-end videos.
Absolutely. Tailwind is all about making your workflow more efficient, which is key for front-end and back-end development, where iterating quickly and testing out different approaches is super important.
This is all fascinating stuff, but
Yeah.
I'm ready to venture into the mysterious world of the back-end now. One video broke it down into 5 key pillars: programming languages, databases, back-end frameworks, version control, and APIs.
It's a good breakdown, a roadmap for exploring all the key components.
Okay, let's go. First up, programming languages. They mentioned a whole bunch: JavaScript, Python, Java, Go.
It's overwhelming. How do you even choose which one to learn?
It can definitely feel that way, but just like with power tools, each language has its strengths and weaknesses. What's interesting is that a lot of them actually encourage starting with JavaScript, even for back-end development.
Wait, really? I thought JavaScript was mainly for the front end.
It is, but one of its strengths is that it can be used for both. So if you're aiming to be a full-stack developer working on both sides of the web, JavaScript is a great tool to have in your belt, like a Swiss Army knife, not perfect for every job, but super versatile.
Okay, so JavaScript can do both. What about these others like Python, Java, Go? When would you use those?
Each one has its own specialties. So Python, it's known for being really readable and easy to use.
You mean a front?
Funnily, yeah. And it's often used when you need to prototype things really fast. Then you've got Java, which is known for being robust and scalable, so it's often used for huge applications like banking software.
And then Go is newer, but gaining popularity for its speed, especially for systems with a ton of users.
So many choices. I guess the best language really depends on what you're building and your personal preferences.
Exactly. Plus, once you learn one programming language well, it's much easier to pick up others.
That's good to know.
Ah.
All right, so programming language sorted. What's next on the back-end roadmap? Databases.
Right.
I'm picturing like a giant warehouse full of servers and flashing lights.
Not a bad image. Databases are basically organized collections of information that your website needs to run. They're like the website's memory, storing everything from user profiles and product details to blog posts.
Okay, makes sense.
Huh.
But they mentioned 2 main types, SQL and NoSQL. What's the difference? Do they have different purposes?
They do. SQL databases are like those old school filing cabinets, super structured.
Everything organized.
Yep. Data is stored in rows and columns, like a spreadsheet. Great for when you need to run complex queries, like find all users in the city who bought this product. The video actually mentioned PostgreSQL as an example of a popular SQL database.
Okay, so SQL is for structured data, like a well-organized library. What about NoSQL? Is it for, I don't know, messy information?
Not messy, but more flexible. NoSQL databases are more adaptable to different kinds of data. Think social media posts, sensor data, or user activity logs. The video highlighted MongoDB as a popular NoSQL database known for handling huge amounts of data really efficiently.
Okay, got it. SQL for structured, NoSQL for flexible. But how do you actually use these databases? Is that where those back-end frameworks come in?
You got it. Backend frameworks are like construction crews for your website. They provide a structure, set of tools, and best practices for building the behind-the-scenes logic of your website. Think of them as the architects and engineers, making sure everything is built right.
And since we were talking about using JavaScript for both front-end and back-end, are there any particular frameworks these videos recommend?
Several, actually, but since we're focusing on JavaScript for full-stack development, they seem to recommend Express.js as a good place to start.
Yeah.
It's really popular, versatile, and works great with Node.js.
Which good.
Oh, sorry. Node.js is a JavaScript environment that allows you to execute JavaScript code outside of a web browser.
Right.
Essentially, Express.js streamlines the process of building the back end of a website.
Okay, I think I see how this is all starting to connect. You've got the front end with its HTML, CSS, and JavaScript, and then the back end with JavaScript, again, a database like PostgreSQL or MongoDB, and a framework like Express.js, like a well-oiled machine.
It is. And speaking of machines working together, that's where version control comes in, which is another key pillar of back-end development and actually software development as a whole.
Version control, is that like saving different versions of your code?
Kinda, but a lot more powerful than just saving different files. Imagine you're working on a group project and everyone's making changes to the same document. It would be a nightmare.
Oh yeah, definitely.
Version control systems like Git, which is probably the most popular one, let developers keep track of every change, work together without overwriting each other's work, and even go back to previous versions if needed. It's like having a time machine for your code.
That's amazing. So
Yeah.
it's essential for collaboration and for keeping your code organized.
Hmm.
What about APIs? They keep coming up in these videos, especially when talking about back-end development.
Right. APIs, which stands for Application Programming Interface, are basically ways for different applications to talk to each other and exchange data. Think of ordering food through an app. The app sends your order to the restaurant system, which then processes it and sends a confirmation back to you, all through an API.
So in terms of websites, APIs allow the front end and back end to communicate.
Exactly. They're the messengers that exchange information between the two sides, making it possible for your website to display information from the database, process what users do, and even interact with other services.
Okay, I'm starting to see the bigger picture. Building a website, even a simple one, involves a lot of different parts.
It does, and we've barely scratched the surface. But the good news is, these sources all emphasize that you don't need to be a coding genius to get started.
You don't.
Nope. It's more about being curious, wanting to learn, and being excited about building new things.
That's reassuring. And on that note, one source we looked at dove into the importance of hands-on learning. They suggested you start building projects ASAP, even if they're small at first.
Totally. They even suggested trying to build a basic Instagram clone to get some real experience using both front-end and back-end concepts.
That actually sounds like a lot of fun. But how do you make sure your code actually works? I wouldn't want to create a website full of bugs.
That's where testing comes in a really important part of web development, especially as you build more complex applications.
Testing. So like running your code and making sure it doesn't crash.
Well, yes, but it's also about writing specific code to check different parts of your application and make sure they're working the way they should. Think of it as quality control for your code. You're basically trying to break your own code to find problems before they reach your users.
So like a team of testers trying to find all the flaws before the website launches.
Exactly. And these sources talked about different kinds of testing, like unit tests, where you test individual parts of your code in isolation, and then integration tests to check how those different parts work together. They even mentioned a testing framework called Jasmine to help you write better tests.
So testing is like a safety net for your code,
Yeah,
ensuring that everything is working correctly before you go live.
exactly.
All right, I think I'm getting that. But one concept I'm still a bit fuzzy on is this object-oriented programming, OOP. It's mentioned a few times, but
It can be a bit abstract, but it's a super important concept in modern software development.
okay, so what's the basic idea behind it?
Essentially, it's about organizing your code into these reusable units called objects. Think of them as blueprints for building things in your code. Each object bundles together data and actions that relate to a particular concept.
Okay. Do you have a real-world example? I'm more of a visual learner.
Sure. Imagine you're making a website for a car dealership. You might have a car object. This object would have properties like make, model, year, color, and price.
Right.
And then it would also have methods like start, stop, accelerate, and brake.
So it's like you're building a digital version of a car with all its characteristics and actions.
Exactly. And you can create multiple versions of this object. So you could have a red Honda Civic, a blue Toyota Camry, and a silver Ford Mustang, all based on the same car object blueprint.
Okay, I can see how that can make your code a lot more organized. One of the sources also mentioned that OOP makes your code more reusable. What did they mean by that?
Well, imagine you want to add a new feature to your car dealership website, something like a loan calculator. Instead of writing that code from scratch, you could create a loan calculator object.
And this calculator could use the data from the car object.
Exactly. You could feed information about a specific car, like its price, into the loan calculator object to figure out monthly payments.
Oh, so you're building these little code modules that you can use over and over again.
Yep. That's one of the key benefits of OP, especially when you're building big applications. It makes your code more efficient and easier to manage.
Wow, we've covered so much just in this first exploration of front-end and back-end development. Building a website, even a basic one, is a lot more complex than I thought.
It is. But what's exciting is that all these sources emphasize that the learning process is just as rewarding as the final product.
And that's what matters, right?
Right. And speaking of the journey, we haven't even gotten into some of the more advanced concepts yet.
Oh, there's more.
Oh, yeah. Things like working with external libraries and APIs, mastering asynchronous programming, and knowing how to handle errors gracefully. All super important stuff.
Okay, I'm definitely ready to hear more about those. Let's take a quick break, then come back and dive into these advanced web development topics.
Sounds like a plan. I'm eager to see how all these pieces come together to build even more complex and powerful websites.
Okay, we're back, ready to dive even deeper into this web development world. We've got the front-end and back-end basics down, but now I'm really curious about some of those more advanced concepts you mentioned, like external libraries and APIs and, what was it, asynchronous programming.
All super important, especially when you're building more complex websites. Let's start with external libraries.
Okay, external libraries. So what are those exactly? Is it like borrowing code from other developers?
Kind of. They're basically pre-written packages of code that solve common problems. Things you'd otherwise have to code yourself from scratch. It's like going to the grocery store instead of growing all your own food.
Makes sense. So instead of writing all the code myself, I can use these libraries to do certain things or add features to my website.
Exactly. One of the videos actually used a really good example, this library called Day.js. It makes working with dates and times in JavaScript way easier.
So like if you were building a calendar app or something.
Yeah. Instead of having to write all this code to handle date calculations and time zones yourself, you can use Day.js and it does all the hard work for you.
So it's like having a team of expert chefs prepping all the ingredients so you can focus on putting together an amazing meal.
I like that analogy, and it saves you so much time and effort. Plus, you're usually getting code written by experts in that specific area.
Okay, I'm convinced. External libraries sound awesome.
Mhm.
But how do you actually find these libraries? And is there like a library for everything?
Probably a library for almost everything. One of the sources recommended checking out package managers, like NPM for JavaScript or pip for Python.
Package managers.
They're basically like app stores for code. You can search for libraries, read documentation, and easily install them into your projects.
So it's like browsing the App Store and downloading a new app, but instead of getting a game or whatever, you're adding code to your website.
Exactly. And just like with app stores, read the reviews, check for updates, and make sure you're using libraries that are well-maintained and have a good community behind them.
Right, that makes sense. So external libraries checked off the list. What about APIs? Those seem like a big deal, especially for connecting different parts of a website or integrating with other services.
APIs, that stands for Application Programming Interface. They're essentially how different applications can talk to each other. One of the videos had a good example. Imagine you're building a weather app that shows the current temperature and forecast.
Okay.
You wouldn't set up your own weather stations all over the place. Instead, you'd use an API from a weather service to get that information from their servers.
So it's like ordering takeout instead of cooking everything from scratch. You're getting the data from another application and using it on your website.
Perfect analogy. APIs let you bring in all sorts of data and features from other services without having to build everything yourself.
This is all pretty mind-blowing. So we've got external libraries, APIs, and then there's that thing, asynchronous programming. It always makes my head spin a little.
It can be tricky at first. It's basically about dealing with delays and making sure your website doesn't get stuck waiting for something to happen. Think about making breakfast. You put a piece of bread in the toaster. You don't just stand there and stare at it until it pops up, right?
Ah, no way. I'd be making coffee, scrambling eggs.
Exactly. You do other things while you wait. Asynchronous programming lets your website do that too. Handle multiple things at once without getting hung up on one task.
So, like, when would you need asynchronous programming on a website?
One really common case is when you're getting data from a server. Say your website shows a list of products from an online store. When someone visits your website needs to request that data from the store's server. If it did this synchronously,
Everything would just freeze.
yeah, the whole website would be stuck until that data came back. Asynchronous programming lets the website keep doing other things while it waits.
Makes sense. But how do you actually do asynchronous programming in JavaScript? I remember those videos mentioning things like callbacks, promises, and async await, and
There are all different ways of handling those asynchronous actions in JavaScript. Callbacks are functions you pass to other functions. They run once a task is done. Promises are objects that represent the outcome of an asynchronous operation, either success or failure. And then async await is a newer feature in JavaScript that basically makes writing asynchronous code feel more like writing regular synchronous code.
wow, that's a lot to take in. Can you give me a simple example of how async await might be used, like in real life?
Sure. Remember that game discovery app? Imagine you need to fetch a list of games from an external API to display on the page. With async await, you could write a function to send the request, wait for the data to come back, then display it on the page, all without hizzing up the user interface.
Okay, I think I'm starting to see how powerful this is. It's like having a whole team of assistants working in the background so
Yeah.
you can focus on the important stuff.
Exactly. It's crucial for making websites that feel responsive and dynamic.
All right, we've covered external libraries, APIs, and asynchronous programming. I've got a lot to learn, but
Huh.
there's one more thing I've been wondering about. What about errors? Like, what happens when something goes wrong?
Oh, that's a great question. Error handling is a huge part of web development, especially when you're dealing with complex systems and outside services that you don't have direct control over.
Hmm. So you're talking about, like, having a backup plan when things go wrong?
Exactly. Think of it like having a spare tire for your car. In JavaScript, one common approach to error handling is using try.catch blocks. You basically tell your code, try this, and if it causes an error, catch it and do this instead.
Can you give me an example?
Sure. Say you have a form on your website where users can sign up for a newsletter.
Okay.
You'd want to handle the case where someone enters an invalid email address. The try part would attempt to validate the email, and if it's not valid, it would throw an error. The catch part would then handle that error and display a message to the user, asking them to enter a valid email.
So instead of the whole website crashing or showing a weird error message,
Right, you can catch those errors and give the user helpful feedback.
this is all starting to make a lot more sense now. We've gone from the basics of HTML, CSS, and JavaScript to these more advanced ideas like external libraries, APIs, asynchronous programming, and error handling. It's really impressive how much goes into making a good website.
It is, and honestly, we've only scratched the surface.
There's still more.
Oh, yeah. But the good news is, with all these tools and resources available, learning web development has never been easier.
So pretty much anyone can dive in and start learning.
Absolutely. And speaking of diving in, maybe it's time to talk about some of the different career paths you can take in the world of web development.
Okay, yeah. We've been focusing on the how. Now I want to know about the what. Like, what can you actually do with these skills?
There are tons of options. Front-end, back-end, full stack. Really something for everyone.
All right, I'm definitely interested to hear more about that. Let's dive into the career side of things next.
Let's do it. It's a dynamic and constantly growing field with lots of possibilities.
Okay, we're back. Ready to explore the career side of web development. We've talked about all the tools, the languages, the concepts. But now I want to know, like, what can you actually do with all these skills?
Well, a lot. The web dev world has tons of different career paths, something for pretty much anyone.
Okay, let's break it down. What are some of the most common roles out there?
I mean, the most basic distinction, the one we've been talking about this whole time, is front-end versus back-end.
Right, right. Front-end developers, they're the ones who make things look good. The artists.
Yeah, they're the ones focused on what users see and interact with. They're masters of HTML, CSS, and JavaScript, creating those visually appealing and user-friendly experiences.
And we already talked about how it's good for front-end devs to have some back-end knowledge, too.
Absolutely. Understanding how data flows from the server to the user's screen can make a huge difference in their design choices and code efficiency.
Then on the other side, you've got those back-end masterminds, the ones making everything work behind the scenes.
The engineers, making sure the data is stored properly, processed efficiently, and delivered to the front end without a hitch. They're the ones fluent in programming languages like JavaScript, Python, Java, Go.
Oh yeah, all those languages we talked about earlier.
They're comfortable working with databases and server-side frameworks.
Okay, front-end specialists, back-end specialists. But what about those who can do it all? The full-stack developers, right?
Yeah, the full stack devs, they're the ones who can build a whole website from scratch, top to bottom.
I bet they're in high demand.
They are. Knowing
Yep.
both front end and back end makes them super valuable.
Okay, so we've got front-end, back-end, and full-stack.
Yeah.
Are there any other specialized roles within web dev?
Oh, tons. The field's always evolving. One that came up in the videos was mobile app development, specifically using React Native.
Oh yeah, React Native, I remember that. So you're saying you could use React to build mobile apps too?
Yep. Build native apps for iOS and Android using the React skills you already have.
So no need to learn a whole new set of languages and tools.
Well, there are still some platform-specific things to learn, but the core concepts transfer over pretty smoothly.
That's amazing. Build a website and a mobile app using the same skills.
Exactly. And that's just one example. There are UX UI designers who focus on making websites really easy and enjoyable to use. Web security specialists, protecting sites from hackers. Data scientists who analyze user behavior and website traffic.
Wow. So many possibilities.
Yeah.
You can specialize in one area, become a full-stack generalist, or even branch out into these related fields.
It's a pretty dynamic field, definitely something for everyone. And the best part is the skills you learn in web development are super useful in other areas of tech, too.
Okay, so someone's listening to this deep dive and they're thinking, this is it, I want to be a web developer. Where do they even begin?
Well, all the sources we've looked at have a ton of advice for people just starting out.
Give me the roadmap. What are the key steps to actually launching a career in this field?
First things first, you need a solid foundation in those core technologies: HTML, CSS, and JavaScript.
Right. Those are non-negotiable.
Yep, those are your building blocks. And a lot of sources recommend those free online resources, like W3 Schools.
I've heard that's a great place to start.
It is. They have interactive tutorials. It's a good way to get your feet wet. Then, once you've got those basics down, the next step is to really dive deeper into either front end or back end, or both, if you're aiming for that full stack path.
And the best way to do that is by building stuff, right?
Exactly. Building real projects, it's the best way to apply your knowledge, run into challenges, and create a portfolio you can actually show potential employers.
Okay, so start small, practice, don't be afraid to mess up, and learn from your mistakes.
That's the spirit. And don't forget about the amazing web dev community out there.
The community.
Yeah. Tons of online forums, groups, and meetups. You can connect with other devs, ask for help, share what you're working on, get feedback.
It's like having a built-in support system.
Exactly. And a lot of experienced developers love to mentor beginners.
That's awesome. Okay, so you've got the learning part, the community. What about the actual job hunt? How do you land that first web dev gig?
One thing they all emphasized is a strong portfolio.
Makes sense. Employers want to see what you can actually do.
Exactly. Beyond that, it's good to network, attend industry events, and practice those coding interview skills.
Oh, right, those technical interviews.
Yeah, they can be tough. Practice solving coding problems, understanding algorithms, how to think through technical challenges.
So much to do. Any other advice for aspiring web developers?
One source gave a great tip. Stay curious and never stop learning.
That's great advice for anything, really.
It's especially true for web dev. It's a field that changes so fast.
Yeah, new technologies, new trends, new ways of doing things popping up all the time.
Exactly. Embrace lifelong learning, keep up with the latest trends, and don't be afraid to try new things.
This deep dive has been an incredible journey. We've covered the front end, the back end, the languages, the careers. It's clear that web development is more than just a technical field. It's a creative one, a challenging one, and definitely a rewarding one.
Totally agree. It's a field where you can build things that make a real difference, connect with an awesome community, and never stop learning and growing.
So, anyone listening out there who's feeling inspired, what are you waiting for? Dive in, start learning, see where this journey takes you. You might be amazed at what you can create.
And who knows, maybe you'll be the one building the next big app or website that changes the world.
That's a great note to end on. Thanks for joining me on this deep dive.
Thanks for having me.